Bismillahirrahmanirrahim. Assalamu alaikum. Before starting my lecture, I would like to pray Allah subhanahu wa ta'ala for his shelter, for our safety against this pandemic COVID-19. The topic for my lecture today is electromagnetic spectrum. As we have already discussed in the last topic chapter, that electromagnetic waves are the waves which do not require a medium for their propagation, and they can pass through vacuum. And other waves which cannot pass through vacuum, they require a medium. These are known as mechanical waves. And we discussed the properties of mechanical waves in detail in the last chapter. Now we are going to learn about the electromagnetic waves. These waves are found in 7 different categories. On the basis of, and this division is on the basis of frequency and or wavelength. These 7 different categories we are going to learn today, and these 7 different categories are termed as the electromagnetic spectrum. The topic of our lecture today is electromagnetic spectrum, means we are going to learn about these different 7 categories of electromagnetic waves, which combinedly is known as the electromagnetic spectrum. Where is the duster? I have put somewhere. It's here. Okay, these 7 different categories are: number 1, the gamma rays; number 2, the X-rays; number 3, ultraviolet; number 4, the visible light; number 5, infrared; number 6, microwaves; and number 7, radio waves. These are the 7 different categories of the electromagnetic waves, which are combinedly known as the electromagnetic spectrum. As I have already told you about this, that these 7 different categories are on the basis of their wavelength or on their frequency. The wavelength range of the gamma rays, X-rays, ultraviolet, visible, infra, micro and radio waves are, I am going to write these in according to these categories of the waves. I am writing these, and this is in ascending order, means the lowest one, and as I am moving ahead, the greater one is coming. It is usually typically in the order of 10 to the power minus 13 meter. X-rays are in the order of minus 10 meter. The ultraviolet are generally, these are in the order of minus 8 meter. The visible light is in the order of 10 to the power minus 7 meter. Infrared are generally in the order of minus 4 meter. Microwaves are in the order of 10 to the power 4 meter, and the radio waves are 10 to the power minus 2 meter to several meters. Actually, I am writing only the one figure over here. Generally, it is not only this wavelength. This is the order. This is the order. This is the range in which all the waves will be called the gamma rays, X-rays, etc., etc. The visible light is a very low band, very small part of the spectrum, and the microwave is also a very smaller part. These two parts are very low band or very smaller part, while the other have the larger range as compared to the other these categories. These two waves are usually utilized for sending our signals or communication, etc. These are further divided into different categories as well. For example, you have must heard about these waves or the radio channel UHF, VHF, SW, MW or LW. Some more categories are also there, but the most important categories of the radio and microwave which are usually used for the communication are UHF means ultra high frequency. Within these range, ultra high frequencies are termed as the UHF, and UHF channel, a particular channels are there in which the radio broadcasting is being done. VHF, short waves, microwaves, medium waves or the lower waves. These are the main categories of the microwaves and the radios. I am separately asking about or telling you about these because these are generally you are using in the daily life for the radio signals or the radio channels. Okay. In the importance in the light of the examination point of view, you should know the order of these. Means I am writing this order of the electromagnetic spectrum in ascending wavelength. If you are asked to write the order in ascending frequency, you will write the 7th first, the 6th number 2. Means alternatively, bilkul totally opposite. 1, 2, 3, 4, 5, 6, 7 means the gamma rays will be 7th part, because the wave which have the greater wavelength will be having the lower frequency, or oppositely the greater frequency means the lower wavelength. Why this is so, we will discuss it in the next topic, that is about the properties of the electromagnetic waves. Now we are going to learn about the properties of electromagnetic waves. There are some categories or there are some properties of the electromagnetic waves. If I am writing the electromagnetic waves, means these properties are for all the electromagnetic waves, all the 7 parts of the electromagnetic waves I have discussed before. Number 1, they all are transverse waves. We have discussed about the transverse and the longitudinal waves in the last topic, last chapter. Means the vibration or the movement of the source and the propagation are perpendicular to each other. That is why they are the transverse waves. Number 2, as these are the waves, they are responsible of transfer of energy. I am not writing the full transfer of energy from one point to another. I have discussed in the last topic that the transfer of energy from one point to another is termed as the phenomenon which is responsible for the transfer of this energy is the waves, and these are the waves as well. So these are the responsible of transfer of energy from one point to or one place to another. Number 3, they show the properties of waves. As we discussed, reflection, refraction. These properties are shown by the electromagnetic waves as well. Simply, you must have seen the light. The visible light is a part of the electromagnetic spectrum. I am telling you about the light because it is very common. You are observing your own face and your own image in the mirror. That is because of the reflection. You have must seen the bending of the light through the glass prism or through the water. You are observing that a pencil is appear bent when it is half sink in the water and half is in the air. You will show the bending, that is because of the refraction. So all the properties of the waves will be shown by the electromagnetic waves as well. Reflection, refraction, there are some more interference, etc. So these properties will be shown by the waves. Number 4, they can travel through the vacuum. They can travel through the vacuum. Before starting this chapter, I told you that the electromagnetic waves are those which do not require a material medium. Means they can pass through the vacuum as well. And in the last chapter, we studied about the longitudinal wave that they cannot pass through the vacuum. So it is the most important property that they can pass through the vacuum. That is why the light and other electromagnetic parts of the spectrum, electromagnetic spectrum's other parts, which we have discussed in the last slide, that they are coming from the sun to the earth. Whether there is a vacuum between the sun and the earth, it is moving all the vacuum and then reaching to the earth. Number 5, they all move with the same velocity, and the velocity of light, they move at 3 into 10 to the power 8 meter per second. It is the velocity with which all the electromagnetic waves move. This is a velocity which is the fastest in the universe, and this velocity of electromagnetic waves is in vacuum. While it is moving through other transparent media, the velocity changes. The fastest is the 3 to 10 to the power 8 meter per second, and that is in the vacuum. When it enters in the air, the velocity decreases somehow, but that is negligible. So we usually use that it is moving with the speed of 3 into 10 to the power 8 meter per second. But when the electromagnetic waves are passing through the water or through the glass or through the wire, different things, different electromagnetic, different media, the velocity of the electromagnetic wave will be different in all the media. Fastest, it is the fastest in the universe, and it is fastest in the vacuum, and that speed is 3 into 10 to the power 8 meter per second. Number 6, they are waves, as we have discussed that they show the properties of the wave, reflection, refraction, etc. So they also obey the wave equation, means V is equals to F lambda, means that the velocity of the wave is equals to the product of the frequency and the wavelength. That is why I write all the waves in the order of ascending wavelength, if you are going to write these according to the frequency order, frequency will be equals to V upon lambda. Since V is constant, so it will be inversely proportional. It is constant, so the frequency will be inversely proportional to lambda, and you will be writing all opposite. Then the seventh will be the first category, and the first in gamma will be the last category if you are writing this in the order of the increasing or decreasing frequency. Okay, so these are the properties of the electromagnetic waves. Okay, I would like to write these waves, their wavelength, sources, and the application. For example, the gamma. For gamma, the wavelength is in the order of 10 to the power minus 13 meter. I write 10 to the power minus 14 previously, now I am writing minus 13 because it is in the bandwidth. It is in the range. It is the shortest wavelength. According to the wavelength, it is the shortest wave, and they can be produced, or their source may be radioactive nuclei. Radioactive nuclei. They can be produced from the radioactive nuclei. Means whenever there is radioactive emission, there may be the gamma radiation also there, and they can be used for radiotherapy. They can be used for radiotherapy. Number one, we have discussed that the gamma rays, where it can be found, means source, or how can we produce, where can it be produced? Sorry, this is the order or the wavelength. We discussed that what is the wavelength here, or where it can be produced, or where it can be found, means it is the source, and this is where we can use it, means it is the application. Okay, so we are discussing about the gamma rays. The order of the wavelength is 10 to the power minus 13 meter. Its source may be a radioactive nuclei, and its application is that it can be used in radiotherapy. Number two, X-rays. Okay, you must have listened about the X-rays, because whenever there is an accident or there is a chance of the breaking of the bones, we refer an X-ray, because by the X-rays we can find that either there is a damage in the bone or not. Yes. X-ray tube, it is the order of the X-ray 10 to the power minus 10 meter, as we discussed already. X-ray tube is the source where it can be produced, and they can be used for medical diagnosis. Or it can be used to diagnose flaw in medicine. This is very important medical point of view. In medical point of view, X-ray has a very much importance. Number 3, ultraviolet UV radiation or the rays. These are in the order of 10 to the power minus 8 meter. You Usually we observe these in the nature. They are coming from the sun. They are produced in the sun. We use mercury lamps. They are also produced in the mercury lamps or the halogen lamp. There are some more sources, but generally we are writing sun. So these are the three main sources we generally observe that ultraviolet rays are produced from. The sun, the mercury lamp, and the halogen lamp. Its application, it causes suntan, it causes skin cancer. It is very harmful. We have first heard about the ozone layer and the breaking of the ozone layer. Ultraviolet are responsible for the cancer, etc. We have studied about it. Stimulated the production of vitamin D. Stimulating the production of vitamin D. Vitamin D production in the skin. It is useful as well. Number 4, visible light. The order of the visible light is 10 to the power minus 7 meter. The sun, it's coming from the sun. The day because of the sun. Any lamp? Lamp, we are using different lamps. The purpose is to produce the visible light for enhancing the vision. Most important use of the visible light is to enhance our vision. It is used in optical fiber as well. And discussing you about the optical fiber, it is the source through which we can pass the light. We are using optical fiber as I use over here because we can transmit the signal in the direction we desire. It is the guided medium for the light. So generally the wire is used for the transmission of electrical energy. In the same way, if we want to propagate our signals with the help of the light, we can use optical fiber for the propagation of the light. Number 5, infrared. IR, 10 to the power minus 4 meter. It is the order warm or hot objects or bodies as well. Any warm or hot object produces infrared radiation, IR. It is usually produced in furnace used for carpent. It is produced for there. The remote controls are a very good use. In every house there is a remote control for TV, hi-fi system, etc. It is used for carrying the signals. It is always required a direction. Whenever you are using a remote, you will directly the LED will be directed of remote LED will be directed towards the television signal, which is remote sensor. It is moving in a straight line. You should direct it to use this remote. Okay. Number 6 I am going to write over here. I'm really sorry that this space is very low. That is why all cannot be written at the same time. I have to erase some part. Okay, number 6. Yes, number 6 is the microwave. Microwave is in the order of 10 to the power minus 2 meter. Source, man-made. Transmitters, it is usually produced by the human being. It is very important for us because we use it in microwaves oven. It is very good for cooking because temperature becomes very high. The carbon compounds in it. Radars are also using it, and we are using it for telecommunication. In mobile signals, etc., we generally use the microwaves. So it is very important for us because every person in the world is using the mobiles, and mobile signals are generally carried through the microwaves. So it is very important. Number 7 and the last is the radio waves. Yes, the radio waves ranges from 10 to the power minus 2 meter, means they are interconnected to each other, overlapping band is here, to 10 to the power 3 meter, means kilometer. It is the longest wavelength. This is the range of the radio waves. It is also used in man-made transmitters. It is produced by the man-made transmitter. It is used for the broadcasting radio or TV programs, etc. It is used for the telecommunication. Okay, so we have discussed different application, wavelength ranges, and the sources of production of the electromagnetic waves over here. So you must have understand that it is where these are electromagnetic waves which are very important for us for using, and their sources where it can be produced, and what are the ranges, why we differentiated this. Their properties are different from each other, that is why their uses are different. They are very different from each other, but these all are very important for us. Yeah, their effects effects of electromagnetic waves. There are two types of the effects. Number 1, ionizing effect. Ionizing, or number 2, non-ionizing. Generally, the non-ionizing are not very harmful. Ionizing are more harmful for us. Ionizing part of the electromagnetic spectrum are the two waves, which are the gamma and the X. ionizing parts of the electromagnetic spectrum, and so they are responsible for ionizing, which which is responsible in DNA damage of living cells. Living cells DNA will be damaged by these two parts of the electromagnetic spectrum, gamma and the X. So these may be very very harmful for the living body, living cells. Okay, and mutation affects to future generation. As we have studied many times, that is still in the Hiroshima and Nagasaki, the people have the effects of the atomic bombardment, because the gamma and X-rays were generated over there and they are causing the mutation effects over there in the generation. It causes the cancer. It causes cancer. So direct exposure of the gamma and X-rays are very very harmful. But still we are using X-rays for medical diagnosis. The medical diagnosis, we are using the low categories of the X-rays which are not very very harmful, and we are using these for in place where we have to